Good morning, greenhouse management students, controlled environment ag students. You should now be into the heating learning unit. But before we talk about that learning unit a little bit, I want to review a couple of points that came up under the lighting unit. First of all, make sure that you look at the discovery video in the Greenhouse Management online website. You have those little discovery videos. Make sure especially that you watch the one that's entitled HID lamps. Hopefully you're watching all of those because they really help with some of the things that you're reading. But under the HID lamps discovery video, I actually show you a quantum sensor meter or a quantum flux density meter, and kind of show you some of the stuff on that, so it'll help you understand that a little bit better. I do want to sort of give you a little bit of information to clarify some things related to quantum flux density, daily light integral, and foot candles. First of all, remember that with quantum flux density, the official unit of measure, the complete unit of measure, would be moles per square meter per second or Einsteins per square meter per second. And you will see that we often then end up reporting it, however, as micromoles per square meter per second or micro Einsteins per square meter per second. That's hard to do because the micro just gets added, because in 1 second we would be getting a relatively small number of photons when you talk about moles. Remember, a mole is 6.02 times 10 to the 23rd. So if you report it as moles or Einsteins, you'd be dealing with this 0.0000. So that's why we often do the micro added on. So we're dealing with a little bit of a larger number that's just easier to manage. So it's okay to say moles per square meter per second or Einsteins per square meter per second. It's also appropriate to say the micromoles or micro Einsteins per square meter per second. All of that's okay if asked what are the appropriate units. Now, I got sloppy, I will freely admit it, on some of my responses in your learning tasks, and I would often say moles or Einsteins, just because I'm grading so many of those. If I wrote that in yours, know that it should be moles or Einsteins with the per square meter per second. Don't drop off the area and the time units. They are very important and are critical in the quantum flux density measurement. Quantum flux density then is the photons within par striking that square meter every second. But a lot of times we certainly want to know the maximum light level and the lowest light level and whatnot that's occurring, so we might want to do those point time measurements. But a lot of times in crop management, particularly with food crops, you'll see recommendations where a certain crop needs a certain daily light integral. The actual amounts are less critical as long as we don't exceed certain ranges. The actual light levels are a little bit less critical than what the plant accumulated over the period of that day. So the accumulation of photons over that 24-hour period. Now with daily light integral, people get really sloppy on the units of measure on that sometimes, but the units of measure for daily light integral should be, in its complete form, moles per square meter per day or per 24 hours. And you'll see now we're using moles because over that long period of time we accumulate a lot. So now it's the opposite. We report as moles because we use the micromole number. It would be a huge number. So now we can just use the moles, and you'll get 10, 20, 30, 40 moles a day, for example. But it is still assumed in daily light integral that it's the accumulation of those photons in a square meter, but per 24 hours. What you'll often see in the literature, though, is we get a little sloppy, and you might see daily light integral reported just as moles, and we assume the 24 hours and the 1 square meter. Or you sometimes will see people reporting moles per square meter, and they are assuming, because by definition, daily light integral is 24 hours. So be aware that people get sloppy on the units on that daily light integral, but it is, rather than a 1 second measurement, it is an accumulation over the day. And oftentimes you'll see recommendations, particularly with food crops, talking about the daily light integral requirement for a crop. Daily light integral and quantum flux density are not the same thing. As I just mentioned, the units of measure are different. They are measuring the number of photons. They are measuring it within par. They are measuring what's being received on a square meter. But one is per second and one is per day. So even though we derive the daily light integral by measuring quantum flux density over a 24-hour period of time, they don't carry the same exact units. So daily light integral and quantum flux density are not exactly the same thing. Another thing I want to touch base on is foot candles. Foot candles are not the same thing as quantum flux density. They're not for a lot of reasons, and those reasons are listed in your notes. Foot candles are an energy measurement. Foot candles, the sensor for measuring foot candle is more skewed or similar to the human eye, so it's more sensitive to energy in the yellow and green ranges. It's not measuring photons. The unit of measure is foot candles for foot candles. So foot candles and quantum flux density are nothing the same thing. But we do have those conversions that I showed you. So if you have a single light source, it's the sun, or it's a particular light source, and only that light source, so we know its wavelengths, we do have those little conversions that kind of allow you in those situations to convert between foot candles and quantum flux density. But they are not the same measurement at all. So that's just some things I wanted to really review from the learning unit related to light. We should be moving now into the heating unit. One of the reasons we often are in controlled environments or often in greenhouses is because at least part of the day or part of the season, the temperature outside, the ambient temperature, may not be adequate or may not be high enough for optimal plant growth. So we often want to elevate the temperature. And the greenhouse structure allows us to actually do that by introducing heat. And as you go through this unit, you will learn things about the types of systems we can use to supply that heat to the greenhouse, the types of fuels we might use to run those systems. You're going to learn about a topic that's very important, just as important as supplying heat. How do we create uniform temperatures and ways we go about doing to create uniform temperatures throughout that greenhouse complex so that we don't have warmer areas and colder areas and things like that. One thing that's in that learning unit that I've left in there would be calculations for heating requirements in a structure. If you have a structure, what's the BTU per hour capacity you need to heat that structure? And that's based on a lot of things: the structure's surface area, the climate you're in, and various variables like wind load and other things. I want you to sort of be a little familiar with how one goes about calculating that. You know, how do you determine that? But I don't want you to know how to calculate the heating requirement on a greenhouse. You won't have to do that math. And the reason for that is there's software out there that you can go, and I'll probably share some of this with you, that you can go find and plug in your things and it will tell you. Or if you're buying unit heaters or you're buying greenhouses or what have you, the companies can tell you. They will spec for you what you need. So it's a very rare scenario that you would ever have to do those calculations. So I want you to understand, yes, they have to. When someone does those calculations, they take into effect things like what's the surface area of the greenhouse, what's the glazing on that greenhouse. Different glazings lose heat at different rates. If you remember those U values and R values and things, what's the lowest expected temperature? What's the lowest? What is the desired temperature you want in the greenhouse? what is the average wind speed. All those things go into calculating an average heat loss from that structure, which then tells you how much heat, typically expressed as BTUs per hour, that you need to put back into that structure. So be aware of that heating stuff, but don't learn how to do the heating calculations. So go ahead and work your way into the learning unit on heating. I will probably be giving you some additional little videos to help you on certain things, and we'll also be getting some learning tasks coming related to the heating unit.